So good morning to all of you and welcome to my presentation today. Can you hear me clearly?
Yes,
Yes, sir.
yes, sir.
Okay, so we are going to discuss the second part of the chapter clouds today. In this chapter, we are going to discuss about now for today's class, we're going to discuss two different aspects. One is we are going to discuss about how the haze and fog can be formed, and in the later of this second part we are going to discuss about the energy radiant budget, which is very important aspect of this atmospheric phenomena. We're going to discuss about that two things. So in the last class we have started the clouds formation process. We discussed how a cloud can be formed, and we also discussed about some prerequisites of the cloud formation, such as condensation nuclei and their types. We also discussed 4 different types of cloud development process. And we also discussed about the formation process of dew, frozen dew, and frost. Today, we are starting with haze. So haze we can define in a way that in particular some of the in the afternoon time, when the relative humidity is little bit more but not approaching 100%, it might be little bit 70 or 75% of the relative humidity, the and air become a little bit cool down. So even if there is some of the condensation nuclei which is hygroscopic in nature, still the water vapor, they are not going to condense, so they remain in the air as a water vapor. So that particular times, that floating particles, some of the floating particles, but they are no larger than the 1/10 of a micrometer. That means very tiny particles. That tiny particles scatter the sunlights. What do you mean by scattering? Scattering means when a component uh, uh, take the sunlights in a one way and they segregate the sunlight or any type of light and distribute different directions, that is called scattering. So those tiny particles, which is 1/10 of a micrometer, that tiny dry haze we termed as a dry haze, that also scattered this type of light. And this light also, when it has been scattered, then if your background is totally dark or black, or you can say dark, then you will see a bluish color of that haze. And if your background is a little bit colorful, that means different color sets, then you can also see this haze as a yellowish tint. So these are the colors we can see because of the scattering of the light, and the way that shows us the particles, it says, we say this is a haze. And mind it that haze should not be in a process that when the relative humidity is nearly reaching the 100%, haze is not anymore, because haze is tiny particles and they remain in the air as a tiny dry haze, rather than it can be act as a water droplet. uh, and then in the night time also, when it cools again and again and the temperature is dropping down, then actually the when it relative humidity goes to 70%, near to 70%, then this condensation may start to begin on the active hygroscopic nuclei. That means those are the nuclei who attracts the water contents. They now started to collect these things, and slowly they come together on top of the nuclei, and it become little bit more greater in sizes, and that produces a wet hedge rather than a dry hedge, which we can see before. But this wet hedge is still very tiny. It's not to look very big enough, and that also has a great capacity to scatter the light. So haze can be differentiated into two different aspects. One is dry haze, which is relatively very tiny in particles, and when the relative humidity goes higher, that means reaches to 70%, 75%, which is still 25% less than the 100% completion. So that 70%, 75%, and with a cool temperature, this haze, they are attracted by the hygroscopic nuclei, condensation nuclei, and then it comes together and it becomes little bit larger, not too large to see, but little bit larger, and they also create wet haze. So this is the formation process of the haze, and haze also restricts the vision, and we can't see very far away, but still it gives us different sets of color variation because of the scattering of the light. On the other hand, so this is haze. So if it is a background is darker, then you can see this is a little bluish in color haze. On the other hand, if you have gradual improvement of that particular relative humidity, that means it can go little bit higher, and gradually it reaches to 100%. That means now these tiny particles, the haze, they cannot remain anymore in their places. Then what they do, they will come together again, and with that condensation nuclei, they are now more active, and these activation also come together to different tiny particles come together, and the droplets now grow bigger and bigger, and these bigger droplets now you can see your open eyes. And because of those bigger droplets, that also restricts our visibility also. And if the visibility is lower than the 1 kilometer, and that air is wet of countless millions of tiny floating water droplets, that's we termed as a fog. So basically fog and haze as two different states of the water bodies in the atmosphere, which can give us two different sets of understanding. One is they scatter light and very tiny in particles, and that cannot be seen and differentiate by the open eyes. On the other hand, fog is little bit more hazy because of the bigger droplets, and it should be wet because of the high amount of the water droplets come together and it makes further bigger, so that's it's become wet. So we can feel it now, feel it very openly, and then it also restrict our visibility because we cannot see more than 1 kilometer with this fog. So this is one type of fogs which can be produced on the top of the mountains or high altitudes. We can expect this type of fog all the way. So fog and haze are two different states, and they can be distinguished between one another by their characteristics. So can you understand now? Is it okay for you?
Sir, can you explain haze, light scattering and viewing again?
Sorry?
I can't understand.
Light scattering.
Yes, sir. Yes.
Okay. So light scattering means when the sunlight fall on a particular object, that light can be act on differently. Some of the light that can fall on a particular object and they can be reflected. Reflection means sunlight come and go away, no entering. On the other hand, when the absorption take place, that means the light that passes through the object and they can be easily pass out with little bit bending. But scattering means when the sunlight pass through a object and they scatter the same light through different direction. For example, a prism. Okay, a prism, when you enter the light in one direction, they take it and then they passes it through absorption process. But sometimes some of the light they can also scatter. You can see some blue light in the sky. Because of the scattering, this blue light, we can see the sky is blue because blue light scatters more. They can go different direction because of its tiny wavelength. So these tiny particles, this haze, which is 1/10 of a micrometer, that means very little. So they have the capacity to to scatter this light. And if this light is scattered, if your background is darker, then you can see totally this light is bluish in color. And if it is colorful, then you can see yellowish tint, yellowish color. So scattering is a comprehensive and insided characteristics of the haze. On the other hand, when your droplets is bigger, then you can also expect that that is a full understanding of the water droplets. So someone asked me, if the question is when does haze occur, answer would be from afternoon to night. Sir, can you give some example of the haze particles? uh, yeah, obviously. So it can be started from the afternoon. That means you need that temperature which started is relatively lower in condition, but also the humidity should not be reaches 100%. It should be less than 100%, relatively 70% or 75%. And also there should be some particles that remain in the air, so that they can easily be find out the places of that condensation nuclei. And as you wanted to know what are the particles of the haze, so it is also water vapor. Haze is also a water vapor. It is not meant to be that haze is different other things. Haze is also a water vapor, but very tiny in nature. So water remaining in the atmosphere, they act differently. For example, we have dew. So dew, they produce on the surface of a object, but in case of haze, they don't remaining on the surface, because they are remaining in the atmosphere. So your answer is the particles is still inside the atmosphere as a water droplets. It not meant to be the other things. But if you wanted to know about something more about the smog, then it should be the combination of fog and smoke. So some industrial city, even in Chittagong also, if you, I can give you a good example. For example, if in the afternoon, if you just move from oxygen to two number gate. So in the way, by the side of the some steel mills, you can see some smog. Smog means it is a combination of smoke and fog. So maybe it is also possible that that time fog might not be possible because of that temperature is not so cool. So maybe the haze and the smoke come together and they give you more weighty components rather than only a smoke. So a smoke is only coming from the industrial sources as a means of vapor of different sets of gases. On the other hand, it can also mix up with the haze so that it can grow bigger, and it also make you the air more polluted, and you will lose your visibility. So fog and haze are the two different states of the tiny particles of the water droplets, nothing more. Is it clear?
Sir, are there any difference between sir mist and sir haze?
Mist is a different thing. That is a one type of precipitation. Okay, one
Yes,
type
sir.
of precipitation. So when you are going to discuss about the types of precipitation in the later of this chapter, we're going to see. Let me just give you the idea a little bit now. Mist can be. Let me see. Is there anything in here about the mist? Yes. So smallest, it's when you say the precipitation can include a different sets of water droplets, and depending on the size of the water droplets, we can also differentiate it as a rainfall, mist, and gaupel, different things. So mist is the smallest water droplet that can be visible, but haze cannot be visible. That means one droplet of the haze cannot be seen by your open eyes. That is the difference between mist and water droplets haze.
Okay,
Is it
sir.
okay?
Yes, sir.
Sadnan, is dew a result of a haze and fog? No, not really. Dew is a in case of dew, you should have a condition that your ground surface objects that should be lower temperature rather than the atmospheric temperature. On the other hand, haze and fog is totally dependent on the atmospheric temperature. Can you get it, Mursalim?
Yes, sir.
Okay. So in case of dew, you have extra some other conditions. That means your temperature of your ground object should be lower than the atmospheric temperature. But in case of haze and fog, you don't need to think about the temperature of your object. You can only think about the temperature of the atmosphere. Okay. Okay. So now this is on first part of the of today's lecture. Now we are going to discuss about the Earth radiant budget. Before I going to explain the total radiant budget, just we are going to some importance of the Earth radiant budget. Budget means you have something and how you can expend it. This is your budget. For example, in your daily activities, we have 10 taka, and how we can use this full 10 taka, that is our budget. Similarly, Earth radiant budget means each of the time, or you can set up a total cycle of, for example, this is only for example, for 24 hours maybe in a particular place. So the total area of this Earth in 24 hours, as the Earth is moving, so it needs 24 hours to come back it again the same positions. So we can say 24 hours, okay? And these 24 hours, how much energy that is coming from the sun, how that can be taken up by the Earth and how that can be released from the Earth. This is Earth radiant budget. Okay, and now why we say this is Earth radiant? Because Earth, because radiation that is coming from the sun, that can be explained in different ways. Someone say this is light, someone can say this is ray, and someone say differently. But we say radiant because this is these are some radiation, and the radiation which is coming from the sun, that not only include the visible light, they also included some other sets of rays, some other sets of radiation, which cannot be seen also in our open eyes. For example, the higher wavelength, microwave, or you can say some heat energy that cannot be seen by your open eyes, or you can say ultraviolet ray or gamma ray or some other type of X-ray. So different types of rays that is coming from the sun, that wavelength is whether it may be large enough or whether it may be tiny enough so that it surpasses the visible light. Visible light only included the wavelength of 0.38 to 0.74 or 76, like this, little bit lower and little bit greater. But rest of the portion we cannot see, but that light also coming from the sun. That's why you say we said it as a radiant energy rather than we say light. So this radiant energy that is coming from the sun, this is actually energy. It doesn't, it not only the light, it is also as a terms of energy. And as we know, energy cannot be created. It can only transfer from one to another. That means it can only change its nature, but not it cannot be diminished, or it cannot be created. So energy which is coming from the sun, it comes to the earth and it uses by varieties of ways. For example, it can heated up the ground or ocean, or it can be used by the different types of vegetation to produce their foods. So different ways it can be uses, and the total energy which is coming from the sun, that should go back to the surface of the earth. So from the surface of the earth, it should go back. It should go away from the atmosphere. If it will not go back, then what will happen? So we know the total average temperature of our earth's surface is 15 degrees centigrade. Now think about if every day some energy which is coming from the sun, the remaining on the earth, and then if it cannot go back, then the earth will be heated up and our temperature will be increasing day by day, and that will not be suitable for us. On the other hand, if the energy which is coming from the sun every time, if the energy which wanted to go back, if it is more than that, then every time the energy is going away from the sun, from the earth, then our earth will be losing its temperature, and then our temperature will be in a opposite direction. That means every time we will lose our heat, and after sometimes after a couple of years, then we're gonna see our average temperature will be lowered down. So that's why earth radiant budget is important. The amount of the energy which is coming from the sun, that should go back every day. So energy budget is equal to, we can say radiant energy budget is equal to the incoming rays minus the outgoing rays. Okay, so the budget should be always in a position that the incoming and outgoing should be in the same direction or in the same amount. So can you understand the importance of the earth radiant budget? Can you understand it?
Yes, sir.
Yes, sir.
Because in your exam it might be, sorry,
I have a question, sir.
yes please.
Uh, Sir, incoming energy and outgoing energy should not be same because the other elements like clouds and vapors are absorbing the energies.
Sorry,
The clouds and vapors and the ozone layers are absorbing in amount of the
Sunlight.
energy that's incoming from solar.
yes.
So how can it be the same, the incoming and outgoing energy?
But that I will gonna explain now. I'm gonna explain now that. But can you understand the importance of the
Yes,
budget?
sir.
Because if the energy remains in here, if the energy remains in here, then the earth will be heated up every time. And if the energy we lose more energy rather than what we get, then we will be cooled down. That is the important thing. Now your question is related to clouds and some other other gases. So how it will be act, I will gonna explain it now. The later just in the next slide I'll gonna explain it. Before that, I wanted to say the importance of the clouds in earth radiant budget, because cloud covers affect the solar radiation which is coming from the sun, and also it also influence on when the cloud when this energy wanted to go back from the earth. That means the infrared radiation. So when the sun rays come from the sun to the atmosphere, so before coming, some of the clouds, they also protect that type of energy to come inside. They reflected it on the top of the atmosphere, so that energy cannot come to the earth surface. That is fine. That makes our earth cool. On the other hand, some of the energy which is inside the that comes to the earth surface and wanted to go back, again the clouds protect it, make a barrier, so that also again heated up. So in both the way, cloud act positively and negatively, you can say, or you can say some of the clouds, they act as they make it cool down, and some of the clouds, they make it hot, heated up. So both the way, they're playing a very important role. So cloud is a very important part of this earth radiant budget. That's why you included these things in our clouds chapter. So using very high resolution cloud imaging instrument, that means satellite imagery, the clouds and the earth radiant energy system, which we termed as CERES, that can also help scientists to determine the cloud properties, such as cloud, what is the width of this cloud, what is the altitude of the cloud, and what is the size of the cloud particles, and different other properties, so that they can also find out the amount of the energy that can be transmitted, reflected, or absorbed by those clouds. So scientists can measure it through this process. Now, we are going to discuss about the total energy which is coming, how can that energy go back. So this is a relatively rough idea because we wanted to know about the segments, how it has been segmented. So don't think about that this is the way how a single area has been impacted. This has been impacted through all over the world. Okay, so think about as a whole, and to make very better understanding, we think the total energy which is coming from the sun is 100% to make our understanding more easier. So when the sun energy come 100%, some of the energy, some of the radiant energy, they cannot pass through the atmosphere. So on the top of the atmosphere, they reflected. So that is 6%. How they can be reflected? As you said, there are different gases in the atmosphere. So some of the gases, they have the capacity to reflect it. So they cannot absorb, they reflect. So those light which fall on that particular tiny gaseous particles, they have been reflected, and that is 6%. So that energy cannot come inside the atmosphere. Secondly, when it come inside further, then that is reflected by the cloud, some of the energy, and almost 20% of the energy which is coming from the sun, that has been reflected through the clouds. So these 20% also cannot come into the earth surface, and then reflected some of the energy on the surface of the ground. So it falls and go away. There is no working inside. So they falls and go away on the surface of the earth surface, because some of the surface of the earth is very polished and very smooth, so that it fall and reflect. So 6 plus 20 plus 4, these 30% energy we cannot get inside our earth surface. Is it okay for you, everyone? So 30% has not come inside to the earth surface for any purpose. So they have been reflected by the atmosphere, by the clouds, and by the earth surface. So now we have only 70% that can come inside the earth surface. That means in the atmosphere and in the ground and ocean. So among that 16% absorbed into the atmosphere. That means the gases remain in the atmosphere, they absorb 16%. And also the cloud, they also absorbed little bit, that is 3%. So 16 plus 3, 19%. And the rest of 51% is absorbed by the land and ocean surface of the earth. So 51 plus 3 plus 16, that is 70%. So these 70 and these 30. So 70% come, and that 70% uses in that way. Now, these are the orange color which has been absorbed. Now you think about the red color. So 64% of this total energy, of total means this 70% energy, we cannot use this 30. So we are now interested about this 70. We are not interested about this 30. So 64% of the energy radiated to space from clouds and atmosphere. That means that is coming from the atmosphere and that is coming through the clouds. And 6% of them are radiated directly to space from the earth. Radiated, that is not reflected, that is radiated. So 64 and 6, that included 70%. So this 64 and 6, it is 70, and this is 30. So 30% cannot come, and this 64% and 6% go away. So 70 plus 30. So you see the total energy which is coming 100%, that is going out. Now the question is, how this is 64%, how this is 70% happened? So it is also very easy. So those are the area you think about, carried to the clouds and atmosphere by the latent heat in the water vapor is 23%. So latent heat is the heat that is carried out by mostly by the water that changes, they wanted to change their state from one to another, vapor to liquid, liquid to vapor, like this. or condensed form. So that is 23%. And then 15% is radiation absorbed by the atmosphere, radiation. So 23, 15, and 7% is conduction and rising of the air. So 23 plus 7 plus 15 is how much? 45%. And 6% is radiated directly to the space. This is our 6%. So 45 plus 6 is 51. So this is our 51%. So anyway, these 51 plus absorbed 3 and 16 all together, this is 70%. So the solar energy which is coming from the sun every day, that should go back in this way, so that there will be no energy remain in here, or extra energy cannot bypass from the atmosphere. But mind it, nowadays we are also discussing about some of the influential greenhouse gases. Cloud is water vapor is one of them. We discussed now that things also, but there are other several gases that can also have influence to retain the temperature inside the earth, such as example of carbon dioxide, CFC, and many others. So these methane or carbon dioxide, they also acting in a way so that the total energy, mainly the radiated energy which is going from the earth surface as a heat energy, they cannot penetrate those type of particles, and they're remaining in the atmosphere, and day by day it increases the temperature. And scientists expected that if this way the temperature is going to increase, then after the end of this century there would be 3%, there will be more 3 degrees centigrade temperature can be added in our average temperature. Mind it, it is in average temperature, not a local temperature. Average temperature means the total average of this earth surface, because in the world we can experience a very high temperature and very low temperature. In the desert area it might be 50, in the Antarctica it could be minus 65. So altogether the average is 15 degrees centigrade throughout the world. And that is very important to maintain this 15 degrees centigrade average. So that's Earth Radiant Budget gives us the opportunity to maintain this 15 degrees centigrade. So now, can you understand how the total energy which is coming from the sun and how they can go away to the atmosphere? So this is our 100%, and it is coming from the sun. And then these 51%, 16%, and 3%, that makes the 70%. And this is our 70%, and 30% has been reflected. So 30 plus 70, these 100% again go back to the outside the atmosphere. And how it has been produced, we're gonna again explain with the 23%, 15%, and 7 means 45%, and this 45% and 6 mean 51%. Is it okay for you? Can you understand it?
Yes, sir.
Yes, sir.
If there is any question, you can ask me. I can explain again it, because it is very important that maybe the question will be in your exam, that how the Earth Radiant Budget works, or we can say prove the total incoming energy is equal to total energy leaving the Earth. Then you can draw this figure, or you can also write down by your own, and you can just make the addition. 6 plus 20 plus 4 is 30, and then 64 and 6 is 70, and this 60 70 is coming from 51 plus 3 plus 16. You can also write down in that way. So someone asked me, sir, can you, sorry, red, sir, can you explain the red portion again? Obviously, conduction and rising air, can you explain it? Fine, good. Conduction and rising air, yes. So the red portion is going out. That means that 70% which is coming inside the earth, both of the cases, from the surface and from the atmosphere, how this 70% go away. This is our red color. So red color included many things. We included carried out clouds of the as a latent heat, conduction and raising of the air. So this is another thing. And also absorbed radiation absorbed by the atmosphere 15%, altogether 45%. And 6% is radiated directly to the space from the earth, radiated directly to a space from the earth. That means coming here to directly go away. There is no other way. Now, someone asked me to explain conduction and the rising of air. Think about the cloud, such as these things. This is the conduction. When the Earth's surface heated up, then this heated up also increase the temperature of the gaseous particles of the atmosphere. Okay, and that's why it become lighter. And when it become lighter, they wanted to go up. This is rising of your air. What you explain in here, this is rising of your air, sorry. This is conduction and rising of air. And this conduction and rising of air, when it is dependent on the surface temperature, because that coming from the sun, that light fall on the ground and the ground become hotter, and that also taken up by the air molecules, and air molecules become heated up, and when it is heated up, they become dry. And this is one of the cause also that the air moves. Without the conduction, without the movement, the air cannot move. So this is another thing to think about. Someone asked me, sir, does cloud absorb radiation when radiation want to go back from the surface of the earth? Yes, obviously. They also do that. Radiation wanted to go back. That's why I'm saying cloud act on both the way. Some of them are coming from the make obstacles when it is coming, and some of them also make barrier when that wanted to go back. Nadia also asked me, sir, why the 6% called radiated, not reflected? Because radiation radiated, because some of the light when fall, they change their behaviors, they change their wavelength. That's why it is termed as radiated, not reflected. When it is reflected, that means the wavelength which is coming, they fall, they go away. There is no changing of their wavelength. But the minute wavelength, when they fall, with they are coming as a light energy, for example, and when they fall, they change it. I said you, the energy can be changed. That means the wavelength has been changed. Energy were same, but the wavelength has been changed. And when the wavelength changed, we termed it, if it is bigger, then we termed it as a radiated. So this 6% is termed as radiated energy, but not reflection. We say reflected energy in here, you see 4%. It is reflected. That means it doesn't change. It fall and go away. But when it is absorbed and when it is transferred and change their behavior, we termed it as a radiate energy. Is it okay for you?
Yes, sir. Thank you, sir.
Okay. So this is very important that we need to understand this radiant budget, so that we can also explain later in another chapter, maybe in climate change chapter. It is also important because in the earth radiant budget, now we are thinking about more about energy which can be stored, which cannot be, which wanted to be released from the earth surface, how it can be released more and more energy through the atmosphere. We are now thinking about those capacities. And also it is very important that some of the greenhouse gases, they are also acting as a barrier. So cloud can also be termed as a greenhouse gases, for example, because cloud can also make some barrier. But again, I should say cloud has two different angles. One is these 20% clouds, these 20%, they make obstacles so that the energy cannot come. So in that way, cloud makes the earth less heated up. On the other hand, the energy which is coming, that is also when wanted to go back, that can also be obstacled by the clouds, and eventually they go away, but at very fast they can also be under the clouds, a very fast barrier, and finally they come back again into the atmosphere and they wanted to go back. So that's why earth radiant budget is very much important. So this is all about for today's lecture. In the next class, we are going to discuss about different types of clouds. because we have come to know that how the cloud has been formed, and now we will see what are the characteristics of different types of clouds in the next class. So if you have any other question, you can ask me, or otherwise we can leave now. Do you have any question?
Sir, I have a question.
Yes,
Uh,
please.
does the atmosphere of a um of our art depends on the gravity?
Sorry.
Does the atmosphere of our earth depends on our
Atmosphere.
gravity of the gases, because the atmosphere is made of many gases?
Yes. So what is your
So
question?
we can see that the Martian atmosphere is very thin
Yes.
and our atmosphere is very thick. Is that because of the gravity difference?
Mm, you wanted to know that why the gravity is different?
No, sir. I want to know that if why is the Martian atmosphere is thin and ours is
Oh,
thick?
no, not that is for gravity, because gravity is a different thing. The gravity, by your gravity, if there is more gases, they can also be attracted by the earth. It's okay, but the main process is when it was originated, after the process, how the gas has been formed. For example, in case of our earth surface, why nitrogen and oxygen is greater in here. On the other hand, many other types of area, other types of planet, they have different sets of gases. Most of the cases, for example, hydrogen, or sometimes different other sets, carbon dioxide and different others. But Martian is smaller or thin because in the very first time when they started to produce, maybe that time their contribution of the producing is less. That's why they are less. And gravity is totally different thing. That is the attraction capacity of a certain planet or certain component in the galaxy. So gravity doesn't depend on the higher or lower. But surely, if there is more gases in the Martian atmosphere, then obviously the pressure will be more. Pressure will be more because that time the Mars also attract those gases inside them. So that time their pressure will be more. But gravity will not be changed because gravity is something else. It is not dependent on how much gas you have or not. Because gravity also attract many other components, not only gases. If you wanted to throw a plane, that also attracted by the gravity, no? If you wanted to send a rocket, that also attracted by the force of the gravity. So gravity is different. That is the inherent capacity of every planet. Is it okay, Miraj?
Okay, sir.
Yes.
Yes, sir. So
Is that
another question is, we know that Martian atmosphere, Martian temperature is very low. Is that why all the water is became ice, polarized caps?
about the Martian atmosphere you wanted to ask me?
So we know that the average temperature of Martian Mars is about minus 60 degrees or 40 degrees, I think. I'm not sure about that. Is that why all the waters became polar ice caps?
Let me
Or
find.
there are no liquid waters are found on Mars?
Okay, let me see. Let me go there first. What is the temperature of the Mars now? You wanted to know that why it is lower in temperature.
No, sir. I want to know that why there is no liquid water is found. Is that because of the temperature is low and all the water,
No,
liquid
not
water
the
becomes
temperature.
solid?
Because of the how they are produced. Because of the what are the materials they have. You see in the Mars they have mostly carbon dioxide. See, so if
Yes,
you wanted
sir.
to know the liquid substance, if you wanted to know, yeah, carbon dioxide can also be liquid form. It can be liquid form because that is minus 60 degree. They can be liquid in a form, but it is not water. It is not life-saving water. It is a different things. And why it is very different, because the Mars is mostly Martian atmosphere is not sorry. Average temperature is minus 60 degrees. So because of the thin cold atmosphere, no cloud of the water on the Mars. Because of the thin atmosphere, because in the atmosphere there is nothing, only carbon dioxide, and very thin. So
Sir,
how can
sir,
they?
I have searched on the website and I found that there are many polar ice caps. If they are
Yes,
melt, there
that
can
ice
be
cap, that
liquid
ice
water.
caps, that ice cap is we are discussing about the atmosphere, no? So in the atmosphere, the greater portion is carbon dioxide. So as you found in there that there is water in there, Mars.
I found that there are many polar ice caps.
Ice
If they
caps,
are melted,
yes,
yes,
that
sir.
can be possible. Ice caps can be possible by the different other gases, can be also carbon dioxide. I said you, it can also be found that in liquid form, different other sets of gases. It not meant to be that this is water.
Okay, sir.
Okay. So if
Yeah.
there is water, then maybe that is also possible that that water is a life containing substances. But we don't have any evidence that Mars have the that much of liquid water that we are expecting for living organisms. So ice caps is okay, and that can be of different sets of other type of liquids.
Okay, sir. Understood. Thank you, sir.
Okay. Is there anything else about today's lecture, what we discussed today? No. Okay, so can I ask Siam that you
Yes,
can
sir.
absent roll number through Google Classroom?
Okay, sir. I'm sending you, sir, immediately.
Okay. So thank you all joining me, and we'll come back again in the next Monday. If everything is
Sir.
okay, we'll come back to Monday. Thank you. Thank you.
Assalamualaikum, sir.
Assalamu alaikum, sir.
Assalamu alaikum.